Okay, in this video, we're going to look at on how to organize and graph quantitative data. So previously, we already learned on how to organize and graph for qualitative data, okay, where we have frequency distribution, pie chart, bar chart, and cross-tabulation table. Okay, that is for qualitative data. Okay, now quantitative data that are measured based on numerical scale. So how we can organize and graph the data, okay? So we can use stem and leaf plot, frequency distribution table. Okay, so this one also similar to frequency distribution as what we already learned in qualitative data, histogram, frequency polygon, and last one is ogive, or also called as cumulative frequency curve. So these are types of tables and graph that we can use to organize and graph our quantitative data. Okay, so this is histogram, cross-tabulation table here. So this is frequency polygon. Okay, so this is ogive, or we call it as cumulative frequency curve. And then this is stem and leaf plot. And last one, box and whisker plot. Okay, also we call it as box plot. Okay, so this is the box and this is the whisker. Okay, before we start with the first graph, look at for quantitative data. Okay, we can organize it. Either we have the raw data it is the ungrouped data itself. Okay, and we can put it into group data. Okay, means that you put into categories or intervals. For example, it says CGPA, variables GPA. Okay, you can put it as, for example, 0 to 0.99, and then 1.0 until 1.99. Okay, and then what is the frequency here? Example. Okay, so this is meant by group data. And group data, we have raw data like this. Let's say 1.49, 3.99, 3.33. Okay, so this is ungrouped data. But when you put into category or interval like this, we call it as group data. Okay, now look at first graph, stem and leaf plot. So what is stem and leaf plot? So basically, it looks something like this. Okay, so and on left hand side here we have the stem, and right hand side we have the leaf. Okay, now look at what is stem and leaf plot. So normally it is used for exploratory data analysis, okay, especially when the data set is small. So in statistics, how small is small? Normally we consider when number of sample less than 30, okay. So this plot separates data entries into leading digits. So leading digits we put or we set it as the stem, and trailing digit as the leaf. Okay. So from stem and leaf plot, it allows us to show the range of data values and shape of distribution. So later on we see what is meant by shape of distribution. Okay, look at the guideline on how to construct stem and leaf plot. Okay, first you split each value into two sets of digits. Okay, so the first set of digits is the stem and the second is the leaf. Okay, for example, 3.4 here, first digit we set it as the stem, and second digit 4 here we set it as the leaf. Okay, and then list all the possible stem digits from the lowest to highest. So it means that you need to arrange your data. Okay, arrange your data in ascending order. Arrange data. Okay, for each value in mass data means raw data like this. Write down the leaf numbers on the line labeled by appropriate stem number. Okay, let's look at example 10 here. Okay, construct a stem and leaf display or stem and leaf plot for the data below. Okay, so this is the raw data or the mass data. So first step, we need to arrange the data in ascending order. Okay, so you arrange the data in ascending order. Okay, if you look at range of numbers here or range of the data here, it starts from 2 until 5. Okay, so first digit just now you set it as the stem, and second digit we set it as the leaf. Okay, we have 2, 3, 4, 5. Okay, so first digit you put it or set it as the stem. So stem here, so first digit start with 2, 3, 4, 5. Okay, and then how about the leaf? So the leaf you take the second digit. Okay, so stem start with 2, so 2.3. So this is for first data. Okay, second data 2.4. So 2 first digit is 2. So this is the second digit. Okay, third data 2.7. Okay, so still start with 2. So this is for third data 2.7. Okay, fourth data 3.4. So now first digit start with 3. Okay, so you move to next row. So you set stem start with 3 here. So 3.4. So this is the fourth data. And then next fifth data. Okay, if you see here, repeating numbers or duplicate numbers. Okay, repeating numbers. So if you have it twice, you need to write it twice as well. Okay, if you did not write it twice, later on your sample will be less than what you have from original data. Let's say original data here you have, for example, 10. If you did not write this one twice, later on in your stem and leaf plot, the sample data will be 9 only. Okay, so if you have 5 repeating numbers, so you need to write it 5 times as well. Okay, then 3.6, 3.6 here, 3.8, so 8 here. Okay, so first digit stem, second digit the leaf. Okay, next number that start with 4. First digit start with 4. So move to next row. So stem is 4, 4.1. So 4.1 here. 4.5, 4.7. Okay, and then last one, first digit that start with 5. Okay, so the stem will be 5, the leaf will be 5.1, next will be 5.9. Okay, then in stem and leaf plot, we need to put some notes here, okay, or some key on how to read this plot. Okay, for example, 2.4 means 2.4. Okay, so this is referring to this vertical line. Okay, so what is the actual value from this plot? Okay, so 2, 3, 2, 4, 5, 5, 1, 5, 9. Okay, so means that, for example, if you read this value, it is actually 5.9. Okay, so if you read this value, the actual value or the original value is 3.8. Okay, 3.8. So that's how we construct stem and leaf plot. Okay, another thing that you need to know in order to construct this stem and leaf plot, okay, make sure the space between leaf is about the same. Okay, meaning to say that like this. Okay, the space between leaf is about the same here. Okay, because why? Later on, we need to see the shape of distribution. Okay, as we look at third point here, shape of distribution. Okay, so this is very important in order to determine the shape of distribution. Okay, so you cannot construct your stem and leaf plot like this. Okay, later on, it will affect your answer for shape of distribution. Okay, example, let's say I start with 2, 3, 4 and so forth. Okay, let's say for 3, we have 3.4 and then you put about this space. Okay, third leaf you put this far. Next you put this far. Okay, so don't construct like this. Okay, later on will affect your answer for shape of distribution or skewness. Okay, so make sure space between leaf is about the same. Okay, usually we interpret stem and leaf plot in terms of the skewness. Okay, so this skewness is now referring to shape of data distribution. Okay, so skewness measures the lack of symmetry in a data distribution. So when we conclude shape of distribution or skewness, okay, either it will be symmetrical or positive skew or negative skew. Okay, so later on we will see this in detail on topic skewness. okay, in calculation part. So for the time being, let's look at on how to draw the stem and leaf plot first. Okay, now let's look at this example. The statistic mark for 30 students taken randomly from the final exam. So this one typo, the final exam. Results are as follows. Construct a stem and leaf display for the data below and comment on the shape of distribution. So how to construct stem and leaf plot? First step, always arrange the data in ascending order. Okay, so I arrange this one first. Okay, how I'm going to arrange this one? Let's say I start with first number 75, and then I look number that start with 7 first. 72, 77, 74, 77, 74, 72, 72 we have twice. Okay, this one depends on how you're going to rank or arrange this number effectively. 71, 70. 71, 70. Any else? 70, 70 again. Okay, now number that start with 5. So we have 52, 58, 52, 58. This one I use method grouping, okay, group based on first digit. 54, 55, 54, 55. What else? 58. And then I start rank number start with 6. 68, 60, 62, 68, 60, 62. And then 63, 64, 63, 64. 60, 68. So we have 60, 68. 65, 62, 65, 62. Okay, then start with 80s. 82, 80, 84. 82, 80, 84. 80, 84 here. Any else? 80, no 80. Okay. And then 90s. 91, 1 here. So this one 53, don't forget 53. And then 45. Okay, smallest number 45. So don't forget 45 here. Done, 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 done. 92. Got 92 here. Done, 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 done. Okay, now first digit, set it as the stem. So here will be the stem. Stem, leaf. Okay, set the first digit as the stem. So now the lowest number is 45. So we start with 4, 5, 6, 7, 8, and last one is 9. Okay, that is first digit. We set it as stem. Okay, now leaf, take the second digit. Okay, make the second digit as the leaf. So 45, so first leaf, 5 here. The second row for numbers that start with 5. So 52, 53, so it must be in ascending order. 54, 5, 8, 8. So 58 we have twice, so you write it twice. Write the leaf twice as well. Okay, now 60, 60 twice, 0, 0. And then 62, 62. So make sure space between leaf is about the same. so that later on we can read the skewness or shape of data distribution. And then 7, 70, 71, 72, 72, 74, 75, 77, and then 80s, 80, 80, 82, 84, I think this one is 84, 84, so 84 we got twice, 1, 2 here, okay, so 84 twice, 91, 92. Okay, and then we put some notes on how to read this plot. So let's say we put here note, okay, 4, 5, this one to represent this vertical line, okay, means that 45. Okay, how to read the actual value. Okay, if you look at the question, comment on the shape of distribution. Okay, let's look at stem and leaf plot, skewness based on stem and leaf plot. Okay, so again here we have either it is the data is symmetry or positive skew, or sometimes we call it as skewed to the right, positive skew, skewed to the right, and negatively skewed, skewed to the left. Okay, so how to determine that? Skewed to the left. Okay, look at symmetrical first. Okay, so when we construct stem and leaf plot, okay, when you rotate it anti-clockwise means to this way, okay? Okay, it resembles a histogram here. Okay, we can see the leaf represent bar of a histogram. Okay, so based on this data, so we can see that the distribution of data is symmetric, or sometimes we call it as normally distributed. Okay, normal, symmetrical or normally distributed. So if you roughly sketch, the shape is symmetric. Okay, symmetric to the right and left is symmetric. Okay, now look at positive skew or skewed to the right here. Okay, so this one, the stem and leaf plot, if you rotate it anti-clockwise, so you must rotate it anti-clockwise, okay, so that the scale is correct. Okay, scale is correct means that, okay, if you rotate this one, so 0 will be here, this stem, okay, 0, 1, 2, 3, and so forth. If you rotate it clockwise, it will be the other way, 9, 8, 7, and so forth. So this is wrong. So make sure you rotate it anti-clockwise. So here, if we roughly draw the symmetrical line, okay, we can see that, okay, longer tail on right hand side here, okay. So that's why we call it as skewed to the right. Okay, later on in topic measure of skewness, we will look at in detail what is meant by normally distributed or symmetrical, and what does it mean by skewed to the right, and another one is what is meant by skewed to the left. Okay, so similarly here, if this stem and leaf plot, if you rotate it anti-clockwise, so it will resemble histogram as well. Okay, so the leaf here represent bar of the histogram. So here we can see that longer tail on the left. Okay, longer tail on the left. So that's why we conclude it as skewed to the left or negatively skewed. Okay. So now let's look at this stem and leaf plot that we already construct just now. Okay, this one, okay, based on this data about student marks, okay, if we roughly sketch it, okay, this one we can see that it is skewed to the right. Okay, skewed to the right. Okay, in statistics, we have two methods in order to determine the skewness or the data distribution, shape of data distribution. Okay, so first based on graph, and second one is based on numerical methods. Numerical method means that we use calculation in order to prove the skewness. Okay, so here stem and leaf plot we based on graph. Okay, graphical method. Okay, sometimes, okay, so for example, in this case, I conclude skewed to the right. Maybe some of you conclude this data, this student mark is symmetrical, okay? Okay, if it is not obvious, if you answer this one symmetrical or almost symmetrical, I still accept, okay? Because this one based on graph. So to ensure whether it is surely skewed to the right or not, okay, so we use numerical method. The one later on we will look at on numerical method under topic measure of skewness. Okay, so here I conclude again how to construct stem and leaf plot. So first we need to arrange the data, okay, and then the first digit you put it as stem and second digit you put it as the leaf, okay. Okay, let's say if you have this number, let's say one student score 100 mark. Okay, how to put this one into stem and leaf plot? Okay, so before this, the first digit you set it as the stem. Okay, for example here 91 we have two digits. So if 100 we have three digits. Okay, so how to put this one in stem and leaf plot? So the stem will be the first two digits. Okay, for example here you put 9, 10. Okay, so if value 100, so the first leaf here will be 0. Okay, so meaning to say that actual value for this leaf is 100. Okay, so that's how we construct stem and leaf plot if we have three digits. Okay, this one is frequency distribution of ungrouped data. Okay, so this one similar to previous that we already discussed in qualitative data. Okay, so for example here you have this data. For example number 2 you have repeating numbers. So example here we put 0, 1, 2, 3 and 4. So for example here 2 it repeated for 8 times. Okay, so that's how we can put these numbers, these repeating numbers into table. So this is for ungrouped data. Okay, now let's look at group data. So for group data, okay, so the data was formed or was organized into group that has intervals, okay. Example, you put like this, okay, 10 to 20, 20 to 30, 30 to 40 and so forth. Okay, then what is the frequency? So that is group data. Okay, this is guideline for how to construct group data. Okay, means that from this raw data, how we can put it into interval like this. Okay, so this is the guideline. So class interval should be mutually exclusive, means that class should be clearly defined and do not overlap. And class interval should be equal width. Equal width means that if 10 to 20, the difference is 10, so make sure second and third group or third row, second and third row here also the width must be 10 as well. It should be neither too few classes nor too many classes. Means that, okay, the number of class here, for example here, 1, 2, 3. This one, 3 number of class, okay. So number of class, guideline as a rule of thumb, greater equal to 5 or less or equal to 15. Okay, so if you have 20 groups, for example, or 20 intervals, so it is not too suitable. And finally, frequency of each class is indicated in the frequency table. Okay, so it means that you need to put frequency for each interval. Okay, now let's look at some terms for group data that we need to know. Okay, first is class size. Okay, what is class size? It is the width of the class. Okay, width of the class. Meaning to say that, for example, if 10 to 20, what is the size? Okay, So how to know this one? Okay, class size is calculated as upper class boundary minus lower class boundary. Okay, so make sure class size using boundary. Because later on we have another term, class limit here. Okay, so remember class size we use boundary. Okay, class limit. So what is class limit? Okay, so class limits of a class are the highest and lowest values of a class. So every class has two class limits, which are lower and upper class limit. So after this, I will explain what is the difference between class boundary and class limits. Okay, next, class midpoint. So it is also known as a class mark. So every class has class midpoint. Okay, so 10 to 20, for example, here, what is the class midpoint? So how to calculate class midpoint? Upper class limit plus lower class limit divided by 2. So since class midpoint, okay, so this one, if you use limit, class limit also no problem. And if you use class boundary also, no problem. Okay, but if class size, we must use boundary. Class midpoint doesn't matter. If you use limit can, boundary also can. Okay, class boundaries. So class boundary are values such that with the values, each class is joined to the next class. Okay, so note here that joined to the next class. So each class has two class boundaries, which are upper and lower class boundary. So what is meant by join to the next class? We will look at some examples to differentiate class limits and class boundary. Okay. So a frequency table can be either constructed with class boundary or without class boundary. Without class boundary means that we will use class limit. Okay. Okay, the class boundary is given by the midpoint of the upper limit of the one class and the lower limit of the next class. Okay, later on I show you some example. Okay, to determine class size and the number of class when ungrouped data is given. Okay, note that this is just extra info. Okay, so in your syllabus, STE 104 does not cover this part. Okay, how to determine class size and number of class. Class size means that 18 to 22, for example, here, what is the class size? Number of class means that here 18 to 22, first class, second class, third class, and this one, fourth class. So in this example, we have 4 classes. Okay, so how to determine number of classes? By using this formula. So again, note that this one is not covered in your syllabus. Okay, so later on, question will directly give you the ungrouped data. Okay, the data that already put in interval. Okay, now let's look at example in table 1 here. Okay, example in table 1 here, it is constructed by using without class boundaries. Without class boundary means that we use class limits. Okay. Okay, what is the difference? Okay, on left hand side here, we call it as lower limit. Okay, so on right hand side here is upper limit. So 22 will be upper limit for first class. 32 here will be upper limit for third class. 18 here will be lower limit for first class, and so forth. Okay, if we use limits, okay, the intervals do not overlap. What is meant by intervals do not overlap here? Okay, intervals do not overlap. Okay, look at upper limit first class and lower limit second class. So 22, 23 means that the class intervals do not overlap. 27, 28 do not overlap. 32, 33 here do not overlap. Okay, so if overlap, what does it mean by overlap? Okay, let's look at next example. Okay, look at frequency table 3 first. Okay, so this table 3 is constructed using class boundary. Okay, with class boundaries. So on left hand side here, we call it as lower boundary, and right hand side we call it as upper boundary. Okay, so 23 will be upper boundary for the first class. 38 will be the upper boundary of fourth class. Okay, 28 here will be lower boundary of third class. Okay, so for this type of table, okay, so if we use boundary, upper class limit of a class is equal to lower class limit of next class. Okay, means that upper class limit, example first class, is equal to lower class limit of next class. So next class will be second class here. So upper limit here will be equal to lower limit of next class. Okay, so that is meant by overlap. Okay, previously if you use limit, the upper limit of a class is not equal to lower limit of next class. Okay, so if you have something like this, so here 28, 28 overlap, 33, 33. So it means that if you have this kind of table, okay, it is using boundary. Okay, but if you have table like this just now, okay, the value upper limit of a class and the lower limit of next class does not overlap or does not equal, the value does not equal. Instead, this table we use class limits. Okay, okay, this table with class limit, we can write it using boundary. Okay, how to convert this table to boundary? You look at example in table 2 here. Okay, so now in table 2 here, look at this one, the value is overlap. Okay, so upper boundary and lower boundary next class here, the value is the same. So means that this is using boundary. Okay, so how from limit just now we change to boundary? Okay, if you look at this point, the class boundary is given by the midpoint of the upper limit of one class and lower limit of the next class. Okay, example. Okay, 17.5 to 22.5. Okay, how we get this interval from this original table? So just now, from limit, how to convert to boundary? Okay, I show for first class, 18 to 22. Okay, how to convert it to boundary? So second class, 23 to 27. Okay, so it is given by midpoint of these two interval. Okay, so how to convert this one to boundary? So upper limit 22 plus lower limit next class 23 divided by 2. Okay, so 22 plus 23 equal to 22 plus 23 divided by 2. Okay, then we get 22.5. Okay, so here this is limit, change to boundary, so here will be 22.5, so here also will be 22.5. So how to change this lower limit 18 to lower boundary? So if here is 18, so class before this one, the value here must be 17, right? So here how we change it to boundary? So 17 plus 18 divided by 2. Okay, so here you will get 17.5. Okay, so this one, how to change this limit to boundary? 32 plus 33 divided by 2. So here you will get 32.5. Okay, this one also will be, the upper boundary here will be 32.5. Okay, if you look at this process, okay, since we find the midpoint, okay, if you look at this table, okay, if you are given a table with class limit, okay, how to change it to boundary? Okay, simply upper limit you plus 0.5. Okay, plus 0.5. Lower limit minus 0.5. Okay, means that here 22 upper limit change to boundary plus 0.5. So here will be 22.5, 27.5 and so forth. Okay. And lower limit here, how to change to boundary? Minus 0.5. So 18 becomes 17.5 here. Okay. So if third class here 28, this one limit, how to change to boundary? Minus 0.5. Okay. So if this one minus 0.5 becomes 27.5. Okay. So this one upper limit of this class plus 0.5. So here will be 27.5. Okay. So 27.5, 27.5. So later on, the value is overlap. Okay, so when the value is overlap, means that one already in boundary. Okay, so you need to know how to change from limit to boundary, because in calculation of class width or class size, you must use boundary, not limit. Okay, sometimes group data also can be constructed using this form. Okay, so this one we call it as open-ended classes. So for example, first class 18 dash, second class 23 dash. So means that how to read this interval? 18 dash means that 18 and more but less than 23. Okay, so if this one we use symbol less than. Okay, so different way in writing interval. This one we use symbol less than. This one we use open-ended classes. Okay, table 3 just now. Sorry, table 2 we use dash here. So how to read this one also similar to this one. Okay, means that 18 and more but less than 23. So here means that 17.5 and more but less than 22.5. Okay, that's how you differentiate class limit and class boundary as well as some characteristic in group data. Okay, if you look at this example, okay, so the data is about weekly earnings of 100 employees. So if you look at this data, so this table was constructed using, so here 600, here 601, okay. So these two values is different or do not overlap. So meaning to say that this table is constructed using class limits, okay. Okay, so you can refer your notes. I already give some example here for second class, okay. So how to change from limit to boundary, how to find the class width or class size. So remember, class width and class size we must use boundary, okay, cannot use limit. Okay, example, okay, this one we use boundary, we get 200, right? Okay, original data was given using limit. Okay, look at second class. Okay, second class here. So this is using limit. Okay, what if we calculate the class width or class size using limit? Okay, so upper class limit 800 minus 601. So this one will be equal to 199. Okay, so look at here. When we use limit, the value is different when we use boundary. Okay, so remember class width and class size we must use boundary. Okay, because later on in calculation of mean, median, mode and quartile values for group data, okay, so if this value is wrong, your class width or class size is wrong, it will affect those measurements. Okay, if you look at here, okay, I give you table. Okay, example. So this class using limit. Okay, now we want to change it to boundary. So as I said before, okay, limit, how to change to boundary? Upper limit you plus 0.5 and lower limit you minus 0.5. Okay, so here second class lower boundary will be 600.5. Here will be upper boundary will be 800.5. That class here will be 801 minus 0.5, we will get 800.5. So here upper boundary is 1000.5. Okay, so these two values are the same or overlap, so means that it is in boundaries. Okay, so you continue until last group. Okay, class width. Okay, remember class width we must use boundary. Okay, cannot use limit. So how we find class width just now? So 800.5 minus 600.5 is 200. So the same thing for third class, 1000.5 minus 800.5 also 200. Okay, so when we construct group data, so class width or class size should be equal width for each class. Okay, so if first class 200, second, third, and the following groups or following class also must be the same. Okay, the class width must be the same. Okay, class midpoint. Okay, class midpoint, you can use either boundary or limit. Okay, so this one you can use limit and you can use boundary as well. Okay, let's check if we use these two values. Okay, let's say if you use limit here, class midpoint 401 plus 600, so midpoint divided by 2. So we get 500.5. Okay, this one if we use limit. Okay, if we use boundary in order to calculate midpoint, 400.5 plus 600.5, so midpoint divided by 2. So also we get 500.5. Okay, so again if we want to calculate midpoint, can use limit and boundary, but if class size or class width, must use boundaries. Let's double check again. So we want to calculate class width. If you class limit, what happen? 600 minus 401 equal to 199. Okay, but if you use boundary, the value is 200. Okay, so different values. So make sure when you want to calculate class width or class size, use boundaries. Okay, class midpoint for second class. Okay, you can use either limit or boundary. So 601 plus 800 divided by 2. So equal to 700.5. Okay, so here 700.5. Third class and the rest also the same. Okay, use limit or boundary, then divide it by 2 for class midpoint. So please complete this table. Okay, note that for example 14 here, as I put in your note here, so this example is not covered in exam. Okay, just for your extra knowledge. Means that in exam it will not give you raw data like this, and then you need to construct the group data. Means that you put or you organize this ungroup to group data like this. Okay, so in exam, group data like this will directly given to you. Okay, so no need to study very detailed about this. This one I just give extra info for you to look at. Okay, now let's look at on how to construct histogram. When you want to construct histogram, remember that we use class boundary. Don't use class limit. Okay, why we use class boundary? Okay, because when we construct histogram, there is no space between bars. Okay, so that's why you need to use boundary. If you use limit, the value here does not overlap, right? So later on there will be a space between each bar. So remember, histogram use boundary. If data given using limit, then you change it to boundary. Okay, if you look at this data, example 15, so this one I already put the data given in boundary. Okay, so 6 boundary, 8 so it means that using boundary. Okay, data below shows the weight of 100 honeydews produced from farm bee. Draw a histogram for the data. So this one, what is the variable? So in this data, weight of honeydews is our variable. Okay, so quantitative variable, weight is quantitative variable. Okay, so since data already in boundary, okay, first step you draw the y and x axis. So again, the scale refer lowest and highest value. Okay, so now lowest value is 4, highest value is 34. So you can use scale of 10 any scale that can fit your histogram in a graph paper. Okay, let's say I put scale of 10, 10, 20, 30, 40. Okay, then put label and title. So Y will be frequency, or if you put number of honeydews also no problem. Number of honeydews. So this one I just roughly draw. So make sure you draw properly on your graph paper. So x-axis will be the variable weight. Weight in 100 gram. So for example 4 to 6. So this data was coded in 100 gram. So if 4 means actual value will be 400 gram. Okay, because this one in 100 gram. Okay, use boundaries. So this data already in boundaries. So first lower boundary for the first class is 4. So 4, 6, 8, 10, 12, 14. Make sure equal space or equal width. Okay, then draw the height of each bar. So 4 to 6. So 4 to 6 here. The frequency is 4. So let's say I just estimate 4 is somewhere around here. And then 6 to 8. The frequency is equal to 9. Okay, so that's why you need to use boundary. If you use limit, later on there will be space between these two intervals. Okay, next 6 to 8, frequency is 9. Let's say somewhere around here. And then 8 to 10, 34. So you draw nicely and properly on graph paper. This one I just roughly draw. So 34, let's say around here. And then 10 to 12, 25. So let's say here is 25. And last group and last interval, 12 to 14 is 28. Somewhere around here. Okay. And then don't forget title. So just put any suitable title. So let's say here we put weight of 100 honeydews produced at farm B. Okay, just put any suitable title. Okay, note that from histogram also we can determine skewness or again shape of data distribution. Okay, skewness or shape of data distribution. So recall when we want to conclude this one, okay, either it is symmetric or symmetrical or normal or skewed to the right. Okay, skewed to the right. Or another one is skewed to the left. Okay, so remember from stem and leaf plot, if you rotate it anti-clockwise, it will resemble a histogram. So if you look at here, this histogram, okay, so if you roughly draw or you roughly sketch the curve, okay, so this time we can see that longer tail on left hand side. Okay, so if question asks you about skewness based on this histogram, so maybe you can conclude it is skewed to the left or negatively skewed. Okay. Later on in topic skewness, I will explain detail on how to conclude skewness based on graph and as well based on numerical methods. Okay, another information that we can get from histogram is model value or mode. Okay. Model value or value mode. So how to estimate model value using histogram? Look at this histogram. Okay, so how to estimate mode from histogram? Okay, first we find the highest bar. Okay, because mode is the highest frequency. Okay, so that's why we find the highest bar. So in order to find model value here, you find the intersection point between bar. Okay, intersection point between bar. So model value you read at x-axis. Okay, example from previous example. Okay, by looking at this histogram, okay, the highest bar is between 8 to 10. So this is the highest bar. Okay, find the intersection point between bar. Okay, not the midpoint. If you do like this, if you cross like this, okay, so this one is actually midpoint. Okay, so make sure intersection between bar. Okay, not midpoint. So how to find intersection between bar? So this one, highest bar or tallest bar, okay, between bar, okay. So this is model value. So you read model value here at at x-axis, okay. So that's how we estimate mode using histogram. Okay, now let's look at this example. The data below shows the employee's age in years. So this data about age in company A. Draw a histogram for the data. So again, remember when we want to construct histogram, we must use boundary. Okay. So this data give you in limits. So first you need to change it to boundary. Meaning to say that at x-axis, value that you need to plot is boundary. Okay, not limit. So upper limit here, how to change to boundary? We plus 0.5. Lower limit, change to boundary minus 0.5. Okay, now let's draw the histogram. Okay, draw the y and x-axis. So y-axis will be the frequency or number of employees. X-axis will be the variable. And then don't forget title. Okay, just put any suitable title. For example, we put employees age in company A. Okay, scale. Okay, look at lowest and highest value. So lowest is 8, highest value is 24. So maybe you can use scale of 5 or scale of 10. Okay, so just any scale that fit your graph. Okay, let's say I use scale of 10, 10, 20, 30. So you draw nicely on your graph paper. Okay, now data given using limit. So when you want to plot values on x-axis here, you must use boundary. Okay, so 18 lower boundary will be 17.5. First boundary 17.5, next 22.5, and then you continue. Use boundary 32.5, 37.5, and 42.5. Okay. So first class employees 8. So let's say 8 somewhere around here. And then 23 to 27, 13. So let's say somewhere around here. Next 15. So let's say 15 here. So this is 15. And then 24. Okay, you draw nicely. And last one is 20. 20 here. Okay, so that's how we construct histogram if data were given using limit. Okay, so you change this one into boundary. If you did not change this limit to boundary, later on there will be a space between each bar. Okay, now let's look at how to estimate model value using histogram. Okay, so look at highest bar. So this is highest bar. So model value, how to estimate. Okay, you find the intersection point between bar. Okay, between bar. So don't confuse, don't find the midpoint. Not here. The one you find midpoint. So here, between bar. So here, read mode value, you read at x-axis. So this one I just estimate. Okay. So read model value here. If you use graph paper, make sure you know one box equivalent to how many you need. Okay. So model value must be between these two values, 32.5 to 37.5. Okay, one model value here. Okay, if let's say you have another group with the same frequency equal to 24. Okay, so means that you have two bars with equal height or equal frequency. So meaning to say that we have two model values. Okay, for example, let's say I add another one class here with the same frequency. So let's say here is 42.5, so here will be 47.5. Okay, you can see a pattern from this data. So the same height here. Okay, so find the intersection of bar. Okay, okay, so this one will be another model value here. So if you have two groups with highest frequency, meaning to say that you have two model values. So in one data, it can be more than one model value. Okay, now let's look at how to construct frequency polygon. So frequency polygon is a graph that is formed by joining the midpoints of each class. Okay, so you join the midpoint of each class. If histogram is available, the frequency polygon is obtained by connecting the midpoints of the tops of the rectangle in the histogram. Okay, so if you have histogram, then you just connect the midpoint also. Okay, two additional classes with zero frequencies are added to the two ends of the histogram. Okay, why we need to add these two classes with zero frequencies? So that our polygon will be closed, or your polygon will touch x-axis, x equal to 0. Okay, for example like this. So your frequency polygon must be something like this. So it must be closed here. Okay, so that's why we need to add two classes with zero frequencies. So here value x equal to 0. Okay, so you cannot draw frequency polygon like this if you did not add these two classes with zero frequency. Later on your polygon will be hanging. Okay, it does not touch at x-axis and x equal to 0. Okay, so this is the first step in constructing frequency polygon. Okay, now let's look at example here. Okay, if you look at this data, okay, it gives you using class limit. Okay, so if you want to start with histogram, make sure you plot using boundary. Okay, since frequency polygon, we construct it by forming the midpoint. Okay, so if class limit is given, so you just find the midpoint. So remember, when we want to find class midpoint, it doesn't matter if we use limit or if we use boundary. Okay, find the midpoint class here. So 121 plus 136 divided by 2, we get 128.5. 137 plus 152 divided by 2, 144.5. Okay, calculate the rest of the midpoint. Okay, once you calculate the midpoint, we need to add these two classes with zero frequencies. Okay, at the two ends. Two ends means that, Okay, class before the first class here and class after the last class here. Okay, so since this one give you in limit, so here after 200, here will be 201 until. So now you look at what is the class width. Okay, so in this case, class width or class size equal to, so this is limit. Class width we must use boundary. So one, for example, take one class here, 168.5 minus 152.5 equal to 16. Okay, so class width is 16. So remember, class width use boundary. Okay, so what is the upper limit here? Okay, so since we know that class width is 16, okay, how to calculate class width? Use boundary. Since this one is limit, so the boundary will be 200.5, so plus 16 equal to 216.5. But remember, this is upper boundary, so if limit, you minus 0.5 here. Okay, so will be 216. So here 216. Okay, frequency 0. Okay, for this part, so that the polygon will close or touch the x-axis. Okay, so class before the first class given here. So if here is 121, so here will be 120. Okay, limit does not overlap. Okay, we know that class width is 16. So what is the lower limit here? So this is limit. In order to calculate boundary, in order to calculate class width, we use boundary. So upper boundary here will be 120.5. So if you want to know lower boundary here, minus. Just now upper boundary plus. So if you want to know lower boundary here, minus class size. So minus 16. Okay, class width is 16. So this one is lower boundary. So if you want to put limit here, here will be 105. Okay, so if you calculate back 120.5 minus 104.5, you will get 16. So the frequency also you put equal to 0. So midpoint here will be 112.5. So last class here 201 plus 216 divided by 2, we get 208.5. Okay. So once you find the midpoint and you add 2 additional classes with 0 frequency here, we can start construct the frequency polygon by drawing the y and x-axis first. Okay, so y-axis is number of occurs or the frequency. X-axis will be the daily sales. Okay, so daily sales here we will use midpoint. Okay, so start with 112.5 class with 0 frequency here. So here 112.5 and then 128.5, then 144.5, 160.5, 176.5. So make sure you draw properly and nicely on graph paper. 192.5 and last one, last midpoint, class with 0 frequency that we add just now. Okay, y-axis scale. Okay, so you look at lowest and highest values. So lowest is 5, highest is 11. Okay, so let's say I use scale of 2, 2, 4, 6, 8, 10. So first midpoint, frequency equal to 0. So here 0. Second midpoint, frequency is 7. So 7, let's say somewhere around here. And then 6. And then 11 here, 11 here. And then 6. here, 5 here, and last one frequency equal to 0. Okay, so how we construct frequency polygon? By connecting the midpoints. Okay, so value that we put in x-axis just now is midpoint, right? Okay, so you just connect the points. So that is purpose we add class with 0 frequency so that the polygon will be closed. Okay, done. Okay, and as usual, don't forget titles. So this data about what just now? Daily sales. Okay, so daily sales of workers. Okay, so just put any suitable titles. Okay, this one if you plot using midpoint. Okay, so just now it says that if we have histogram, okay, so the frequency polygon is obtained by connecting the midpoints of the tops of the rectangle in the histogram. Okay, let's say we have histogram here. Let's say I delete this first. Okay, let's say we have histogram. So how to construct the frequency polygon? So first you need to add two class with 0 frequency. Okay, so here you add another class. Okay, so frequency 0. Here also you need to add another class. Okay, so make sure you have enough space to add these two classes. Okay, so when we draw histogram, so this is value boundaries, right? Class boundary. We use boundary. Okay, when we want to construct frequency polygon, we just connect the midpoint. Okay, so midpoint will be in the middle of each bar here. So for example here, 0 frequency, so midpoint will be here. Here will be the midpoint. Okay, so this one if you want to construct frequency polygon from histogram. Okay, and then just connect the midpoint. Okay. Okay, now let's look at cumulative frequency distribution. So what we have done before is only frequency distribution. Okay, now cumulative frequency distribution. Okay, there are two types of cumulative frequency distribution, less than, which is the most frequently used, and more than. Cumulative frequency is determined by adding the frequencies. Okay, so we add frequency. The frequency up to upper boundary of each class interval are progressively added and the cumulative totals are placed in a new column. Okay, so later on we look at the example. Okay, look at how to calculate relative frequency. So relative frequency is frequency of that category. For example, this category divided by sum of all frequency means that total frequency here. So that's how we calculate relative frequency. Percentage relative frequency, so if percentage multiply by 100. Okay, now let's look at this table. Okay, calculate the cumulative frequency, relative frequency, and cumulative relative frequency. So if you look at here, we have 6 classes. Okay, so with boundaries given. Okay, not limit, boundary. 29, 29, 31, 31. So boundary. Okay, so this is the frequency. Okay, first find the total. So 2 plus 9 plus 13 plus 14 plus 8 plus 4. So total will be equal to 50. Okay, cumulative frequency. So first class here 2. So cumulative 2. Okay, so means that the first frequency is 2. Cumulative means we total up the frequency. Okay, 2 plus 9 we get 11. So next cumulative frequency will be 11 plus 13 which is 24. And then next plus frequency to the next class 24 plus 14 38 38 plus 8, 46, and 46 plus 4 will be equal to 50. So last cumulative frequency here must be equal to total frequency. Okay, relative frequency. How to calculate relative frequency just now? Frequency of this category or that class divided by total frequency. So for second class, the relative frequency, so frequency is 9 divided by 50, we will get, so 9 over 50 equal to 0.18. Next, 13 divided by 50 equal to 0.26. So next, 14 divided by 50 equal to 0.28. Fifth class, 8 divided by 50 equal to 0.16. And last class, 4 divided by 50 equal to 0.08. Okay, if we want to find cumulative relative frequency, so if cumulative, you add the relative frequency. Okay, so 0.04, the first class, so 0.04 plus 0.8 will be equal to 0.22. And then next class, the cumulative frequency 0.22 plus 0.26, so equal to 0.48. Okay, next plus 0.48 plus 0.28. So here will be 0.76. Okay, next 0.76 plus 0.16. So equal to 0.92. And last one plus 0.08. So here will be equal to 1.0. Okay, so total must be equal to 1. Okay, later on, when we want to construct ogive, the next graph for quantitative variable, okay, so ogive is another name for ogive is a cumulative frequency curve. So when we want to draw ogive, so make sure you know how to calculate cumulative frequency. Okay, now let's look at ogive. So ogive is a graph or a line chart of a cumulative frequency distribution. So when you draw ogive, it must be looks like as shape like this. Okay, so less than ogive is an increasing function. So this one is less than ogive. Okay, increasing function, increasing. Contradictorily, if we draw more than ogive, so more than ogive will be decreasing function. Okay, so like this. So this is more than ogive. So for syllabus, we just cover less than ogive. Okay, so in order to get this increasing function, okay, so we must use cumulative frequency. Okay, so if you did not use cumulative frequency, later on your ogive will look something like this. Okay, because this one referring to frequency for each class. Okay, so in order to get that S shape or increasing function, okay, increasing function, so we must use cumulative frequency. That is the first step. Okay, look at this example. The following frequency distribution shows the age of Takaful insurance agent at a particular agency in Kuching, Sarawak. Okay, draw a less than ogive for data below. Okay, now this data give us in limit, okay, using class limit. So this is the frequency. Okay, so first step, look at guideline on how to construct ogive. Find the cumulative frequency. So here, calculate the cumulative frequency first. 5 plus 10, 15. 15 plus 23 is 38. 38 plus 32 is 70. 70 plus 12, 82. Plus 4, 86. Plus 2, 88. Okay, step 1 done. Look at step 2. Draw X and Y axis using suitable scale. So this one depends on your data. Okay, look at lowest and highest value. So here lowest will be 5 and highest will be 88 because we use cumulative frequency. Okay, so in this case maybe we can use scale of 10 or maybe you can use scale of 20. Okay, doesn't matter as long as can fit in your graph paper. Okay, x-axis is using class boundary. Again, when we want to draw or GIF, we must use class boundaries. Okay, so that's why it is very important for you to differentiate between class limit and class boundary. Okay, so note here that data is in limits, okay, using class limit. So later on, when you want to label x-axis here, it must use or it must be labeled by class boundaries. Okay, that is second step. Okay, third step, start plot the first point at x-axis using the lower boundary of the first class. Okay, the cumulative frequency of this point is set equal to 0. Okay, start plot first point at x-axis using lower boundary of first class. Okay, example I show you here. Okay, so this one must use boundary. So the first point, lower boundary of first class. So this is first class. Since this is limit, using limit, so boundary here will be 25.5. The cumulative frequency of this point is set equal to 0. So you set here equal to 0. Okay, so when you draw a J, this S shape, okay, this point must touch x-axis. So that's why we set the frequency equal to 0. So please make sure that your ogive does not hanging like this. Okay, so make sure it touch at axis. So next at this point, you use next lower boundary of second class. So this is limit. So lower boundary here will be 30.5. Okay, so the frequency is 15. Let's say 15 is here. Okay, then continue. So next point will be next lower boundary, which is 35.5. Okay, then you continue. Next frequency 38. So when we use cumulative frequency, later on we will get the S shape. Okay, so you continue plotting the cumulative frequency. Okay, now let's draw OG for this example properly. Okay, now let's look at on how to draw the OG for example 19 just now. Okay, you draw as usual y and x-axis. So y will be the frequency, which is number of agents, and then our variable just now is about age. Okay. Okay, so remember label for means that point for x-axis we must use class boundaries. Okay, so just now first group or first class here is 26. So this is limit. So change the boundary. So 26 here will be 25.5. So here 25.5. Okay, next point here, continue use lower boundary of next class. That means that 30.5 here. So 30.5, continue, here will be 35.5, 40.5, 45.5, 50.5. Okay, last class until 60.5. Okay, scale for y-axis, so total just now is 88. So because of limited space I had here, so I use scale of 20. So you can use scale of 10, no problem. Okay, so title, don't forget. So let's say we put here less than or J for the age of takaful agents. Okay. Okay, look at how to draw a GIF just now. Find the cumulative frequency, done. Draw X and Y axis using boundary, done. Okay, look at number 3. Start plot the first point at X axis using lower boundary of first class and set the cumulative frequency equal to 0. So at 25.5 just now, we set it equal to 0. So here, lower boundary of first class, we set equal to 0. So here, 0. Okay, next. Lower boundary, you continue plot using the cumulative frequency value. Okay, so just now the first cumulative frequency is 5. So let's say 5 is here. And then 15. So 15, let's say here. Next, 38, 38, let's say somewhere around here. And then 70, 45.5, 70 here. And then 82, 50.5, 82 here. And then 86, 86 somewhere around here. This one I just estimate. And last frequency or last cumulative frequency is 88. Okay, for 60, this one should be 50.5. So here will be 55.5. Okay, so here 55.5. 55.5 and last is 60.5. Okay, so last point you must use upper boundary of last class here. So last 88. Okay, so this one I just estimate. Okay, then you draw the curve by connecting those points. So when we use cumulative frequency, so later on you will get this S shape or increasing function. If you did not use cumulative frequency, later on you will get something like this. Okay, because it refers to the rises and fall of the frequency. Okay, now look at this question. Based on the OGIF, estimate the following. Okay, A, number of agents who is more than 34 years old. So if we want to estimate number of agents here, so this one based on frequency. So meaning that answer will be at Y axis. Okay. Okay, B, also number of agents. So your answer will be at Y axis. Percentage of agents who is more than 53 years old. So if percentage means that multiply by 100. Okay, find percentage. Okay, now look at A first. Okay, make sure you draw your OGIF properly in order to get a more accurate estimation. Okay, this one because I'm using drawing pad, so it is hard for me to draw very smooth curve for OGIF here. Okay, number of agent who is more than 34 years old. Okay, 34 years old. So each we set it at x-axis. Okay, look at that at x-axis. Okay, you must know within this interval where 34 years is located. Okay, so if you use graph paper, so you must know one box equivalent to how many units. Okay, so let's say I just estimate here my 34 is here. So this is my 34. Okay. Okay, if let's say I just give example, let's say you use 10 boxes, okay, 40.5 to 45.5, you use 10 boxes. So 10 box equivalent to 5 unit. Okay, how I get 5 unit? 45.5 minus 40.5 equivalent to 5, right? So you must know one box equivalent to how many unit? So 1 box equal to 5 divided by 10 because you used 10 boxes just now. So 5 over 10 is 0.5. Okay, if 34, so you estimate where 34 years old is located. Let's say I just estimate my 34 is here based on this scale. Okay, we want what just now? Number of agents who is more than 34 years old. Okay, draw the intersection line that touch to the curve. Okay, example. Okay, draw the line here. Make sure you draw properly. Okay, then read at y-axis. What is the value? Okay, here you read. What is the value? Here y equal to what? Okay. Okay, let's say I just estimate here y equal to 16. Just example, make sure you estimate, read the value accurately from your graph paper. Okay, if you look at here, y equal to 16 is for agents who is less than 34 years old. Okay, why less? Okay, look at the area here. So from here to here, 34. Okay, this area means that for less than 34. Okay, so question asks us for more than 34 years old. So if more than 34 years old, the area will be this side. Okay, so this is agents with age of more than 34 years old. So what is the frequency or number of agents who is more than 34 years old? So since we know that less is 16, so if more, so you use total frequency here, okay, the last cumulative frequency minus agents who is less than 34 years old, then later on we will get those agents with more than 34 years old. Okay, so I repeat. So this area y equal to 16 here, this is for less than 34 years old. Okay, pink area here, less than 34 years old. So if we want more, the area will be here. So how to know the frequency? Total frequency here, which is 88 just now, minus less, then we will get this area. Okay. So what is the number of agent who is more than 34 years old? So total 88 minus 16 equal to, so this one I just estimate, okay, 16 I just estimate. So you use your graph paper, read it accurately, maybe you will get different answer, means that not equal to 16, okay. So here will be 72. 72 agents, each more than 34 years old. Okay, question B. Number of agents who is less than 40 years old. Just now more. Now less. Okay, if more, we subtract 16 from the total frequencies. Okay, if less, so this one 16 just now less, right? So question B, less, that means that your answer you read directly from the graph. Okay, 47 years old. So again, you find where is 47 located. Okay, let's say I estimate my 47 is somewhere around here. Okay, 47. Okay, as usual, find the intersection point. Okay, read at y-axis. Okay, number of agents, you read at y-axis. So let's say here I estimate my value y is, let's say I put it as 84. Examples. Estimate accurately using your graph paper. Okay, if you look at here, even though 80 to 100, here is around 90. So note that our last 3 point here is 88 just now, this one 86, this one 82. So that's why I just put estimation of 84 here, okay? Okay, we want number of agents who is less than 47 years old. So this area represent agents who is less than 47 years old, okay? 47 less, okay? So this is less. So you just read directly from the graph. So this one, the answer is 84. Okay, see percentage of agents who is more than 53 years old. So again, more. Okay, delete some of the shaded area here to avoid you confused. Okay, now read where is 53. Let's say my estimated 53 is here, 53. Okay, then find the intersection. Okay, let's say here why I estimate it around 85. Okay, so again I just estimate. So use your graph paper and read it accurately. Okay, 85 here is agents who is less than 53. Okay, so this area is less than 53. So if you want more, use total minus those who is less than 53 years old, then we will get this area, okay, who is more than 53. So 53 to the right means more lah. So if to the left means less. So the answer here 88 minus less 85 in order to get more. So since we want to find percentage divided by total 88 percentage times 100. Okay, so when you calculate this one, you will get 3.41%. Question D, less, you read directly from y axis. Percentage multiplied by 100.